Procuring enough water for a family to simply survive the day in a rural community often requires walking miles across unforgiving terrain. When that distance is too great, families often pull water directly from stagnant, contaminated rivers. The resulting exposure to waterborne diseases undermines health, halts education, and drains local economic stability. Solving this usually involves drilling a deep commercial well, but the logistics are expensive. Bringing in heavy machinery and specialized contractors carries a price tag between $5,000 and $10,000. For a village of subsistence farmers, that cost creates an insurmountable barrier. Without a massive outside donation, the community remains physically bound to the daily walk and trapped in a rigid cycle of water insecurity. Equipping Farmers International, or EFI, bypasses this capital trap using a method called hydro-percussion. It reaches shallow groundwater resources without the need for a single piece of heavy commercial machinery. This shift changes the project's economics. This chart shows the drop from a $10,000 commercial operation to only a few $100s for an EFI-trained community well. You achieve this massive cost reduction by substituting expensive diesel-powered motors with human kinetic energy and basic physics. By lowering the financial barrier, clean water stops being an external gift that a village must wait for. Instead, it becomes an internal, achievable enterprise that the community can fund, build, and manage themselves. The entire drilling rig fits in a rural field. It centers around a simple tripod frame that serves as the foundation for the entire operation. To manage the heavy lifting, the team uses a basic rope and pulley system attached to the top of the frame. It's a mechanism built from locally available materials. The real work, however, happens out of sight at the bottom of the drill shaft. This is the drill bit. It features a pointed tip and specialized fluted edges designed to shatter packed earth and rock on impact while disrupting the soil around it. When you attach this bit to a heavy pipe and drop it from the tripod, the force mirrors the output of a heavy industrial drill. The process relies on a synchronized rhythm. A local team uses the rope to repeatedly lift and drop the heavy iron drill pipe. Gravity drives the heavy bit downward, fracturing the earth below. As crushed rock accumulates, water is poured into the shaft, creating a muddy slurry. Every downward strike acts like a piston, forcing mud up the hollow pipe, clearing the hole automatically. Mastering this simple physical loop is the key to self-sufficiency. It allows a community to reach water using their own labor, rather than relying on external fuel or machinery. The immediate result is direct access to clean water, which removes the daily burden of collection and improves overall community health. But the construction process itself is a classroom. To build the rig, the local team acquires industrial skills like metalworking, welding, and fabrication. These technicians also learn the mechanics of pump maintenance. They gain the ability to repair their own equipment and troubleshoot systems without ever needing to call an outside engineer. This technical literacy creates a foundation for local employment and entrepreneurship. A team that masters these skills can transition from maintaining their own well to providing professional drilling and repair services for the entire region. This expertise creates a multiplier effect. Newly trained technicians often travel to neighboring villages to instruct them on how to build and operate their own rigs. A single successful well project can eventually evolve into a regional training and service network, where knowledge is passed from village to village. The ultimate outcome is a total regional transformation, driven by local agency and technical ownership. Real success occurs when the need for outside assistance fades away. By equipping a community with the knowledge to build its own future, a project ensures that the transformation remains sustainable for generations.